I will share the screen.
Yeah. All right. Exciting to see so many participants today. Hello, everyone, and welcome to today's webinar, which is organized by the Strategic Innovation Program in Sweden. My name is Fredrik Lekarp, and I'm the Deputy Manager of the program. One of the most exciting developments related to transport infrastructure is the ability to use connected vehicles to gather data on pavement damages. And that is an innovation which not only increases efficiency, but also contributes to safer and more sustainable roads. In this webinar today, we'll focus on a rather groundbreaking project initiated by the Swedish Transport Administration, Trafikverket, which through an innovation procurement process partnered with Mercedes-Benz Sweden, Niro Dynamics, and Universys. The goal of the project has been to develop and demonstrate services that enable collection of road surface data using connected vehicles. And we at Infra Sweden are proud and happy to have been able to be a part of this project and follow its development. During the session, we'll highlight key lessons from the project, explore opportunities and challenges, and gain insights into additional work ahead. So we hope that you find the webinar both inspiring and informative. So let's get started. Bodil?
Yes, thank you. My name is Bodil Sandén, and I am one of the innovation leaders within Infra Sweden, and I will moderate this webinar. As you can see here on the title page, this webinar will be recorded and shared on Infra Sweden's LinkedIn page, and it will be, once it's published, it will be available for 2 weeks. So you can spread it to your colleagues that weren't able to join us today. Let's look at today's agenda. First, we will have a short project introduction by Hashim Karim from the APM, followed by the results from measurements that have been done by VTI, that is the Swedish National Road and Transport Research Institute. Thomas Lundberg will hold that presentation. And then we will have a panel discussion on the results and learning and what's next to come with Fredrik Lindström from Trafikverket, Håkan Frank and Björn Zachrisson from Niro Dynamics, Jonathan Selby from Universys, and Adela Spulber from Mercedes-Benz. And finally, we will let the suppliers and service deliverers present other relevant research and innovation projects. And about 2:30, we will try to wrap up and end this webinar. No time to lose. Hafshin, fire away.
Yeah, thank you, Bodil. Just me
stop sharing.
Stop sharing and let me share my screen. So, hello everyone. My name is Hashim Karim, and I'm one of the development leaders in the Infra Sweden.
Okay.
And I will give you a very short description or introduction to the project for those who have never heard about the project before or haven't heard anything. This will be very short introduction, and more details will be published very soon in a report which will be given by Trafikverket. So what is connected road surface monitoring and what initiated the project? Bodil, do you see my?
No, we can't see him. No, and we can't see you either.
Yeah, okay. So connected road surface monitoring, it's a research and development project.
You still don't share anything.
Sorry, just let me see. Start me. So do you see now anything?
Now something. Now we can see. Thank you.
Great. And for your information, is that in Sweden, the assessment of road condition are, you see, no, you don't see the right screen. It's always, it should be the right screen. No.
I think this is good.
Challenges, we see challenges.
You see challenges. Yeah, great. So in Sweden, assessment of road conditions are annually conducted during summers. The assessment gives the Swedish Transport Administration, Trafikverket, detailed information, which is fundamental for the planning of the pavement maintenance actions. However, the rapid condition changes that happens between those conventional assessment cannot be considered in the planning as a systematic and cost-efficient way for the assessment of those changes are missing today. This means that for some of the roads, the real needs of maintenance actions is not really considered in the planning process, especially for the roads that suffers from poor roughness during winter due to, for example, frost damages and frost heaves and other things that happens in the road construction in the Nordic countries. So this was the main reason for initiating the project by Trafikverket. And as I said, this an R&D project aiming to develop and evaluate one or several technical solutions for the systematic assessment of rapid condition changes. And the focus is on the floating car data from, let's see, from connected vehicles and using artificial intelligence. And it's also worth to know that from the beginning, we started the project was the focus on pothole, frost damages and winter damages. Those damages, we believe that there is already some technical possibilities to assess and identify by connected vehicles. And let's see. So the project started 2022 with an innovation procurement, including development and evaluation of the technical solutions. And under the first phase, the procurement was announced by Trafikverket, asking for a declaration of interest. And as Fredrik said, this was an innovation procurement. And in this phase, 20 or 14 applications were received by Trafikverket. And after a qualification based on 2 parameters, 12 of the companies were qualified to the phase 2, and the requirement were basically an access to the an existing vehicle fleet and reference from similar projects made by the suppliers or the bidders. And phase 2 started by creating a more detailed procurement documentation by Trafikverket with specific goals and requirements that must be fulfilled by the bidders. The procurement were later announced, and 10 bids were received by Trafikverket. And in this phase, a qualification process started based on a combination on a maximum price and added values. And the added values were calculated based on maturity of the existing solutions and the plan for the development of the solutions during the project. 3 of the bidders were qualified then and signed contract with Trafikverket, Naira Dynamic, Mercedes-Benz, and Universys. Naira Dynamic and Mercedes-Benz have similar technology based on data collected by existent sensors in the cars, so no post-mounted sensors or technologies. However, universities have also a very interesting technology based on image recognitions and artificial intelligence using mobile phones mounted in the collection. This was also a beginning for the phase 3, where the development and the evaluation work started, and each supplier established own pilot area for test and evaluation. And even this phase 3 was divided to 2 stages with a sort of midterms qualification to see the progress made by the suppliers. And 3 types of activities were chosen for the evaluation, and the result is currently used for the ongoing qualification of the supplier to the next phase, which is the phase 4. And basically the implementation and the upscaling of the used technologies, one or all the 3 technologies for the main reason of the project, namely the assessment of road condition or road service conditions, or what we call the connected road service monitoring for the entire state-owned road network in Sweden. And we'll stop here, and as I told you before, more details about the project will be soon available in a report given out by Trafikverket and the project parts.
Yes.
So back to you, Bodil. Thank you.
Thank you, Hashim.
Let me see.
Now, yes.
So
Now we are very curious about the results from the measurements you have made, Thomas. Please go ahead and share your findings with us.
Thank you. I will try to start the presentation.
Looking good so far.
Yeah, so far so good.
Yes.
So is it the right
No,
presentation mode now?
no, we see föredragshållarvy.
Yeah, okay. That's better.
yeah,
Better. Perfect.
Yeah,
Thank you.
good. Yes, my name is Thomas Lundberg, and I'm working at VTI at the Department of Maintenance and Operations. And this presentation has been done by me and my colleague Peter Andrén. And I will tell you some details about 2 activities we have done in this project. Activity 2, it's comparative measurements with reference and the supplier. And activity 3, a randomly selected test from fleet measurement of the supplier versus the reference. And as you have heard, the suppliers are Naira, Mercedes, and Universys. And in the presentation, they will be named suppliers. We have worked with this project for about 1.5 years on commission of the Transport Administration. I also have to mention that that has been a constant development from the suppliers during the project. So it's products that has been improved, and there are also new products from the suppliers that are been worked out during this 1.5 year. And the focus on the evaluation has been to look at the evenness measurement from the suppliers, but also to see the possibilities to detect defects like objects, potholes, and cracks, and so on. And the focus has also been to see how the suppliers could detect the high or poor condition sections that is in need for operation and maintenance. The variables we have used to compare from the reference, our measurement car, with the suppliers are IRI, the International Roughness Index. It's a standardized longitudinal evenness measurement index that are describing the evenness in the wavelength band from 0.5 to 30 meters approximately. We have also used the local roughness index. It's a national longitudinal roughness index that detects unevenness with a short longitudinal presentation length, like potholes, bridge joints, and etc. And also two RMS values, 2 and 3, they called. RMS2 describes evenness defects in the wavelength band from 1 meter to 3 meters. It has been used to detect a snowy road surface by comparing a bare road with a snow road. And the RMS3 is describing evenness wavelengths between 3 and 10 meters. It's really used to good detection for frost heave. So that's the variables we have used from the reference measurements. And all these variables can be measured by an ordinary profilometer like the VTI RST that is used in the project. I will not go into very close to the suppliers because Havshin just did that. But from NIRA Dynamics, we have looked into two variables really. The IRI values from NIRA, that's presented in 25-meter presentation length. And the reference for that is, of course, IRI when we are comparing, but also obstacles or anomalies from NIRA Dynamics. That's a way to detect extremes at the road surface. And the reference for this is the local roughness index. From Mercedes-Benz, we have evaluated the IRI value. They give an IRI value at 10-meter presentation length, and we have evaluated the IRI at 20 meters. So we have made an average up to 10 meters, of course. And they have also delivered, and we have evaluated the RMS2 value and the RMS3 value. But also something called the surface event, that's extremes, like the NIRA anomalies. And we have used the local roughness index for reference there. From Universes, we have evaluated the potholes. They give the pothole as a geometry, and you can calculate an area of the pothole and get some severity rating of that. And we have used as reference the local roughness index, evaluated at 20 meter, and also visual inspection to verify the results. And the Universes also has a measure or a index called the damage level. That describes an overall damage level of the road section. And the reference for this has been visual inspection. And finally, cracks, the geometry is given by Universes. And the reference for this is visual inspection. And also Universes has developed the index RMS3 in presentation length 20 meter. And we have, of course, used the RMS3 from the VTI RST reference vehicle. So let's describe the first activity. I just have to look at my papers a little bit. The purpose with this activity is to establish a good comparison between the reference and the supplier data. For that reason, we have done dedicated supplier and reference measurements in Dalarna. It's not necessarily the same variable compared between the supplier and reference, but of course, in those cases where we can compare the same index, we have done that. For instance, for the potholes detected by universities, we have used the local roughness index to compare with. As I said, VTI RSD is a reference. It's a standard measurement vehicle as used for network road monitoring for the Transport Administration. We have calculated the data and position from 1 meter level from the reference, and this enables an exact matching with the supplier data since we have coordinates for all data from the suppliers. Then we can match the exact position from the reference with the suppliers, and in that case, we could do a very good matching of the data. The activity 2, there were 4 road sections selected in Dalarna, and there were 3 sessions. 23 September 23, good condition, I would say summer condition, and then to winter condition 24 in March and April. And sections A to C was measured in all sessions, and D was only measured in the 24 session. Every supplier and reference did 2 measurements per session. That gives a total of about 500 kilometers measured each session for each supplier and reference, of course. So this is the sections. It's close to Mora, where we started the measurement. And the section A was north at road 70. It was about 82 kilometers. It's a road with a quite good condition. We had an IRI value. You can see the IRI value in the table here. It's 1.28 in the summer conditions, September. So it's quite a good road. Then section B, a smaller road with I would say an uneven road, IRI about 2.4. And finally, in the north, section C, a very uneven road with an average IRI of 4.2, 4.3. And section D was added in the winter, so we didn't measure that on the September measurement. That's a road that is partly very even and partly very bad. It had so-called winter damages. An IRI in the winter condition about 1.8 millimeters per meter. And this is the increase in percent between the winter condition and the summer condition. So approximately between 10 and 20% higher IRI values we got in the winter condition. We have tested the suppliers with 3 methods. Something like we call the rank method. In this method, I will explain that later, we rank the supplier and the reference, and we compare the ranking. So we look at the ranking from the reference, and then we see what ranking the supplier has, and we compare those measurements or those measures. And we also have a method called normalize method. In that method tries to normalize the supplier to look like the reference as good as possible. I will also explain that a little bit later. And we have used limits 0.5 millimeters per meter for IRI to get an approved, so-called approved value from the reference, from the supplier. And for RMS 2 and 3, 0.2 millimeters and 0.4 millimeters. And the rank method, we have a limit that is plus minus 15% of the ranking from the reference. That's okay for the supplier. But we also have compared the original data between the supplier and the reference. We have used the same limits for S described above. And one final thing, we have only compared the data where the reference has ranked the measures as bad, so the 50% highest ranked values has been evaluated. So the ranking method, you have the data, and then you rank the data from low to high. So the highest value gets 100% and lowest 10% in this case. So if the reference is ranked 80% at this section, the supplier data is approved with a rank between 65 and 85%. So this is the plus minus 15%. And the normalization method, this is the original data from one supplier. As you can see, the distribution of the data is some different for the low values, but also for the high values. And after the normalization, we get a better agreement between the reference and the supplier data. So this is the second way to analyze the data or evaluate. And the third was, of course, the original data without any normalization. This is an example of the section A, the even section in Dalarna, Road 70. The top diagram shows the comparison between the reference in black and the supplier NIRA in this case. So this shows that the agreement is really very good on 20-meter level, 25 in this case. The same comparison with Mercedes looks very good at the same section. And finally, the Universys RMS 3 value looks also very good. It's a good agreement between the supplier and the reference, I would say. And this is some results from aggregated results from the comparison with the three methods, the rank method, the normalization method, and the original data compared. And as you see, this is the index we have tested in this. We are aggregated or presented in this diagram or table. It's the IRI, the fleet data from NIRA, and the test vehicle that we did measurements with at the Dalarna test sections. And this is the test vehicle for Mercedes-Benz, IRI, RMS 2, 3, and 4, and the Universys RMS 3. So the rank values are between 56 up to 85%. Within plus minus 15% from the reference. I would say it's good results. The normalization method, it's this, for example, this explains that 67% or 68% from Mercedes-Benz IRI measurement was within 0.5 millimeters from the IRI at the normalization method. But the original data in this case was about 59%. So I would say this is overall good results for all suppliers, I would say. Okay, and this is some results for each supplier and each section. So you could see the section C where the most uneven road were. We have a better rank result for all suppliers. So the very high values can be very good detected by the suppliers. And there are little lower values for the even sections. We have also looked at the local roughness values from the suppliers. So in this analysis, we have looked at the agreement between the top 1% in this column, from where the reference has located the top 1%, and we have compared that with NIRA's obstacles, where we have used all data detected from NIRA in this category. And from Mercedes-Benz, we have used the surface events or jerks. We have selected jerks or surface events over 25. And from NIRA Universes, we have looked at potholes with an area over 0.5 square meters. And I did a note of that. Universes are detecting potholes. It does not automatically correlate to a rough road. So that's not as fair comparison as the others. But if you look at this column, it's the top 1% highest local roughness values from the reference. And in this case, Mercedes-Benz had 96% detected jerks over 25 in this category. So it's a very good result. And also NIRA had about 80%. And this is the category where we looked at the 15 highest percent of the local roughness values. And in this category, both NIRA and Mercedes had almost 100% in this category for their surface events and damages or obstacles and surface events. So I would say this is a very good aggregated result on the local roughness detection. If I should summarize activity 2, overall it's very good results at aggregated level. There can be done more analysis or explaining or investigation at object level. It's a little bit more to do there. And a more thorough analysis of data coverage must be done. So overall, it's really good results. In activity 3, we have compared the VTI RST and the supplier fleet data. We got access to fleet data from suppliers in Dalarna and Gävleborg län. We randomly selected 10 sections in 3 categories of the supplier fleet data. Level 1 was road sections with some or minor defects. There were 2 sections selected. Level 2, there were some defects, a little bit higher ranked, 4 sections. And level 3, severe defects, 4 sections. And the selection was randomly done among this category from the supplier fleet data. And the section was measured twice with the reference VTI RST. And this shows an example of the waviness or IRI from Mercedes-Benz. As we can see, the low level, the even sections were also even from the reference system. So this is what Mercedes-Benz has measured on the different levels, and this is the reference measurement. So every section has the same supplier data, of course, and we have did 2 reference measurements, so this is a repeated measurement on the same section. But it was a very good result, a good comparison between the different level of roughness between Mercedes-Benz fleet data and also IRI from the reference. The local roughness, there were some outliers, I would say. Some sections had very high local roughness from the reference that was not detected by Mercedes-Benz. And also in category 2, there were one section especially that had very high local roughness values. So this comparison, if you count out those outliers, I would say you had a quite good agreement there also. NIRA activity 3, the IRI comparison between the reference and the fleet data from NIRA. Quite good agreement. The level 2 and 3 was not easy to detect any difference from the reference measurement. They were quite the same level, but the most uneven sections were detected as uneven from the reference also. And finally, the anomalies, local roughness from NIRA. We have a very good agreement between the local roughness from the measurement vehicle reference and what NIRA has pointed out as anomalies in the data. For universes, we have looked at data from Gävleborg and looked at 3 variables: damage level, it's a kind of overall road condition in 3 levels, and potholes, area of pothole, and cracks. We have only done some short evaluation of that. And these features has been compared with visual inspection. There were Trafikverket had done the visual inspection, and they rated the sections in 3 categories. So there were 10 sections with damage levels in different levels, 10 sections with potholes, 10 sections with cracks that were visually inspected and rated by the visual inspection also. And then we compared the visual inspection with the damage level, pothole, and cracks. The inspection rating was 1, 2, and 3. The 1 was some or minor defects. The level 2 was defects, and 3 severe defects.
Nu har du ett par minuter kvar.
Yeah, okay. Only two or 3 minutes, I would say. The results for damage level 3 from universes. The result of the visual inspection was the rating 2, 3, and 1 and 1. And the comments from the visual inspector was frost cracks and local bearing damage, edge slump and cracks, generally uneven, or brittle pavement, raveling poor older repairs, repaired cracks and potholes. So I would say quite good result, overall good result. And all the level 3 level from universes was visually classified as worst. Also, that's good. 1 section in damage level 2 was without any visual damage. And finally, results for potholes, level 3. The results from visual inspection was rating 1, 2, 1, 1. The comments from the inspector was raveling, old pavement, potholes in the middle of the road, potholes in the middle of the road again, and potholes poor elderly repair. So overall, it's a good results for the pothole detection. There was always not potholes detected at the sections. It could be as they could have been repaired. Universe's pothole level 3 had potholes in 3 out of 4 sections, so that was really good. And just a quick example of the crack detection from Universes. So this is the results of the cracks visualized on the road in Gävleborg. And this is what the visual inspector photographed. So you can see the cracks very, very good here. And we also looked at the section in PMS V4, the payment management system from Trafikverket. And in this, we have a lot of cracks in this section also. So it's a good agreement, I would say. Now, thank you for your attention.
Thank you, Thomas. We have a question from Björn. Fire away.
Yeah, I mean, there was the question about the slide because I was looking at numbers, but was there a mix of a single vehicle manual collected data with a dedicated vehicles and also the fleet? Was it mixed in the same result?
You mean at, let's see, in this one?
Yeah, exactly.
In this case, it's the fleet.
And all the other ones are single vehicle.
And this is the single vehicle, yeah.
Okay.
Yeah. We have fleet data from Mercedes-Benz also, but we have not had time to do that analysis.
Yeah, no, I was just curious because I didn't have time to read because I was listening at the same time.
Yeah.
Thank you.
Thank you. Any more questions now for Thomas? No? If you come up with any, please write them in the chat, and Thomas will answer them for you.
Yeah, of course.
Good. Thank you, Thomas.
Thank you.
Time for the panel discussion and for Trafikverket and the suppliers to comment on the result. Please welcome Fredrik from Trafikverket, Jonathan from Universes, Adela from Mercedes, and Björn and Håkan from Mira Dynamics.
Thank you.
I'm going to start with you, Fredrik. What's your comments on these results?
Yes, thank you for the presentations, and of course, thank you for the participation in this project. It's been very interesting and challenging for the last 2 years, and we've been working hard together on this. I mean, our comments from the Trafikverket side is, of course, that we see that, as Thomas said, the results from that we've seen is good, and we have confidence in this data. Of course, we are a little bit. We're still in the project, and we are hoping to continue next year, and we're in negotiations about that. So I will be quite boring in that sense and not say too much from our side. It's been really interesting. I have a few general questions for the rest of the panel to get started, and I would say so. First one is, what do you think is like the in short term, what do you think is the biggest obstacle to make use of this data in payment management in general? And then when I ask that, not just for Trafikverket, I mean for road holders in general, what would you want to see? What obstacles do you see is the biggest ones in short term?
Would you like to start, Jonathan?
Sure. Yeah. Okay. I'm Jonathan. I'm the CEO at Universes, who's one of the 3 suppliers, and I think as Fredrik said, it's been great to be part of this project. I think really, you said at the top, a really groundbreaking project. I think everyone sees this future where connected vehicles are driving around all over the place and collecting data, and that can be used in very interesting ways for the management of the roads. I think what we observe when we talk to not just Trafikverket but other players around Europe in particular, I suppose, in terms of obstacles of adoption is understanding what data exists, understanding how that data can be used in the context of the road management operations today, but also how those road management operations have to evolve or can now evolve to take advantage of those new data sources, and in particular the rate at which that data is produced. And I think there's sometimes confusion and misunderstanding and lack of clarity over exactly what is provided and how it can really add value. And I think if you think about obstacles, I think that possibly is one of them. Just clearly communicating exactly what data is provided and how it can really add value. Because one of the things we've talked about here is from Thomas's point of view is the data itself and what's actually being collected. But of course, that's just the starting point. Actually, there's a lot more to be done with the data to integrate it into the workflows and the operators who actually carry out the work on a day-to-day basis. And so I think that part of it, I think, is a big piece as we go forward, a very clear communication as one of those suppliers. Not only what are we providing in terms of data, but how can it then be used within the operations to really make a difference, to add value, to save money, to save time, to increase safety. So I think that's a big piece for us about communication and clarity over the value.
Adela, what do you say?
Yeah, so to build on what Jonathan said, for me the keywords are trust and data quality. I think the evaluation that VTI did is very important, and it's kind of the first step in creating trust in this new form of data from connected vehicles and other technologies, more like the image-based recognition that universities have, because road authorities have been working with data from lasers and radars for decades. They know how those technologies work. They know what to expect from them, but they don't know exactly how these newer forms of data analytics relate to these conventional forms. And this is, I think, the biggest obstacle we need to overcome, creating those those bridges, those correspondences, and maybe one day having standards for measuring road performance metrics that are truly independent of the technology with which they are measured, such that someone can use independently laser-based technology or connected vehicles with information coming from the wheels or the chassis movement or image recognition. I think that's the most important thing for us in this new, let's say, segment of the industry, creating trust in data quality with more research like the one we just had.
Thank you. Björn, do you agree, or do you see other additional obstacles?
No, I think I can second what both Adela and Jonathan is saying. And also, I mean, the time aspect, we've been lucky to be a Swedish company. It started out a decade ago working in Sweden, and been working with the Swedish Transport Administration, Trafikverket. But to drive a change is time consuming. And even if we can make it happen, all the national road authorities are big authorities. And in order to make a change that actually it is changing the way that they're working, it requires a lot of work and a lot of time. It's not enough to, I mean, the technology is out there, and I think it's very usable. I mean, disregarding what technology, but to make a change in the way that you're working, to leave what you have been doing to do something different, there has to be a good reason and a motivation. but also a will to change, because I think it's very easy to be comfortable in just doing what you did yesterday. At least I think that's easy for me to just do the same things. The change is always it's more troublesome. So I think that the change management is by far the most challenging part. And then before you actually get some value on the side from the receiver of the data, there's a lot of things you need to do before you can realize the full potential, I think.
Before you tell your other questions, Fredrik, what is Trafikverket's plan to drive this change?
Yeah, good question. I think this project is obviously one of the big. I mean, it's one of the big reasons we're doing this is to be in the forefront and try to use the possibilities that are out there in best way. We think it's absolutely something that we can gain from and make better decisions if we have better information, of course. So I think that's probably it's what we're doing and what we're trying to do. And connected to that, maybe if we look a little bit further, if we look like 5 or 10 years ahead, what do you think will happen within this area? What's the main like future development areas that you see in your services, and how do you think it will work together with your clients and the road maintenance sector in general? So that's my second question.
Let's start with Adela now. 5 years from now.
Yeah. So
do you have anything new or something totally different that you're planning or anything like that?
So unfortunately I cannot make any product launch announcements in the workshop, so stay tuned for that in our on our websites, but I think in general in the next years what we expect to see, a mix between what we expect to see and what we hope to see, is to go through the segments of customer groups whenever a new product comes. Like now we are, like Trafikverket and some others in Europe are, let's say, in those in the first categories that like organizations that are eager to try out new things, new technologies, and in the next years we expect to see the early majority coming in. So as we get a better understanding of what exactly are the use cases that these technologies, these new data sources can address, and also to have some concrete proof how it helps authorities, a bit like what Björn said. So now in this project, Trafikverket started working with the data, started understanding how good the data is, has an idea, first idea of pros and cons, strengths and weaknesses, and now can start to understand how to integrate it into the systems. And only the next years will tell what are the real benefits of the technology, not just the expected ones. And then based on that, we expect to see more road authorities adopting these data sources, if indeed there is a proven added value.
Thank you. Björn and Håkan, 5 years from now, where do we stand? And you start.
Yeah, I think we have more ideas than we can handle. So we tried, I think it was 2 years ago, we kind of did a interview throughout Europe with our partners and users to figure out what is most important. And in the long run, I mean, we want to be able to provide the same level of service that you get from a dedicated vehicle put on the road, and adding the camera images from the vehicles and also the LiDAR as it becomes more and more a commodity in the vehicles, and being able to extract in the beginning features, but in the long term, maybe we can extract the actual scannings. But there are a lot of hurdles to get there. So I think 5 years ambitious, knowing the limitation of the bandwidth, but also the privacy parts of things. But we are looking into how we can solve any problem with the road authorities, pretty much, and knowing that a laser scanner will always be better. In the terms, if you take your today's classes, the laser will always be better because that's what you're used to and that's what you're using. And also that we had in the VTI investigation, that is the ground truth that we're comparing against. But looking to what advantages it comes from the high frequency data, it becomes a different tool. So I think our step-in part would be to start screening a lot of things. So not giving the 96.47, but rather saying good, bad, or needs actual some kind of a more in-depth investigation in those scenarios where we cannot tell what might be wrong. And that goes for road quality, potholes, lane markers, signs, structural bearing capacity, and all the areas that we are currently working on. And of course, the freeze-thaw issues in the northern parts of the world or the colder parts of the world, and winter damages in any area that suffers from winter-treated roads. So it's a lot of areas, but in general, getting into the high-frequency domain of measurements, I think that's the biggest step change in getting that adopted around Europe and the world where we operate.
Good, thank you. Jonathan, you're next.
Yeah, well, I think it's super interesting actually, because projects like this are having an influence, not just in the domain of road management, but further afield. And if you think about what we're talking about, the supply chain of this data is the automotive industry, right? And what we have to ask ourselves is, why is the automotive industry going to be interested in supplying data to the road management market? What's in it for them? And I think that's why this is becoming super interesting, because it's these projects which, through our connections into the automotive world, we can then go and talk to the automotive industry and say, here is an opportunity for you. Here is an opportunity for you to say, not just build your cars as usual and then whatever is produced as a byproduct, use it. Actually think, even today at design time, is a use case for you. That actually you can start to build your cars, perhaps not exclusively for the domain of road management, but at least think about that as you make your cars. And what that means then is that the hurdles perhaps that you were talking about, Björn, not perhaps privacy, that's a separate one, but perhaps some of the technical problems that might be come to the fore are thought about already, so that when future vehicles come off the production line in 5, maybe 10 years time, maybe further afield, actually a lot of what they produce is already been thought about. Road management might be a particular application domain. And what that means is that the raw data that is produced from these vehicles at scale is actually that much more fit for purpose, that much more specific to what the problem space of the road management domain is, and therefore that much more valuable, and that much more sort of virtuous circle starts taking place as the data is better and more fit for purpose, the road managers are more accepting. And so that change we talk about and the hurdles that exist with change, already we can start to influence today because of projects like this. So this is what I see in 5 years' time, maybe a bit further down the field, that already the seeds we're planting today in the automotive industry starting to influence, say, start to think about this industry today as you build your new cars. We'll start to reap those rewards further down the field. And actually, to your point, Björn, all of these assets that we are talking about, white lines, street lights, barriers, not just the pavement, will start to come into scope, because the cars, they're sensing all of that already, right? They are doing that today. And actually, it's all about harvesting that and making it useful in the context of road management.
Thank you. Fredrik, what do you say when you hear this?
Yeah, it's really interesting to hear, and I think we have a bright future in this area and a lot of things that will happen the coming years. I noticed there are some questions in the
let's
chat.
open up.
Of course, more are welcome. The more the merrier. I think we have a lot of some time at least.
Yes. Fredrik Lekar, you have a question.
Yes, I had a question not particularly related to this project, but about the concept that was used and resulted in this project, and that is using an innovation procurement. That by itself is groundbreaking, and I was thinking, I was wondering if Trafikverket has, what are the conclusions they have drawn from using such concept to push for advanced development, and have you used it in other areas? Are there any concrete plans?
That's a good question, and I'm not sure if I can answer it completely because I'm not sure about everything that's going on. But I know this project has been like an inspiration for other projects and procurement. So I don't know if there's anything similarly done in the last couple of years, but I mean the general conclusion is that it has worked well. We are really happy with the result of the procurement, and it was difficult, of course, to do it. It was a lot of work to make it happen the way we wanted it. But the end result was good, and I think that's something that we have tried to spread within our organization, and we've had some of course dialogue internally around this, but I can't give you any really concrete answer if it's used in other areas or not.
I think we can agree that the more you do it, the easier it will get.
Yeah, absolutely.
Good. Are there any more questions in the chat?
There was one about Våra vägar, the map. That Transportföretagen, the I don't know how to translate it, the organization for the transport companies presented a couple of years ago. It's really maybe not that strongly related to this project, but it is anyway. We have something similar. So if you haven't seen it, the link is in the chat there, våravägar.se. It's a map of the condition of the roads according to the analysis that they have done. Obviously, it's based on the open data that we provide. So it's based on the condition measurement, the traditional condition measurements that we do at Trafikverket. And of course, we have our own condition assessments internally based on the same data. We use the system that we call PMSv4, pmsv4.trafikverket.se. It's open for anyone. You can't get the exact same result from that, of course, because it's somewhat different analysis, and we also don't provide the future analysis that they do. But we're working on it internally, and it might be something that we present externally as well in the coming years. I would say maybe not in the very short term, but maybe in the future. So it's very unspecific answer, but we have ideas.
Great.
Yes.
Okay, I get a report from Lisa that there are no more questions in the chat. So let's move on to the next and final item on today's agenda. And we will continue to look outside the project and see what else is going on. And I'm going to let Björn start.
Yeah. Let's see. I added some slides because I think it's always nice to be able to show something. But let's see if it works at the full screen. Can you see my screen?
Perfect.
All right. So I just wanted to, the idea was to talk about things that are not within the project. And one of the things we have been looking into is also the lane marks or road markings. So I will just do a quick run through of outside of this project scope, things we're doing. And this is typically something that we can observe. This is a road on the highway in Sweden, and I've been commuting this one for 2 decades. So I know it by heart, and I also know why it looks like it does. But what we can see here, number one, is that we're flagging it as it's poor visibility on lane markers because it's red. And as we can see in the image, there are no images, or no lane road markings. And then in number two, they are back visible again. So they are seen also in the interface. And then on picture number three, all of these three are within a couple of 100 meters. They are disappearing again. And the phenomena behind it, I didn't think to bring up just to showcase the things that we can do beyond the scope of this project, so kind of doing a expansion or learning from other projects. This is also something we're doing with the Swedish Transport Administration. And just another picture of how it can look like where it's completely gone. And then another view where we just empty out the lanes, of different ways of visualizing it, but also giving some examples of how you can perform a screening, because saying that, again, the exact number, how visible they are, it's really hard. But to do a screening to say where the visibility is good and where it's really bad, or where they have changed, that is much easier. And that is kind of the things we want to support with, to do a screening, network-wide screening of all the roads in lane markings quality. And something that is more closely tied to what we're doing is the structural screening. I mentioned it briefly, and this is something we spent a lot of time with after we came across this example when it's a road with 3 segments on. One was repaved in January and one in August. And the third one wasn't repaved, and these 3 are adjacent to each other. So it was 2 go out and repave the section, but the third one wasn't. It was different timings, and that was due to that the roads kind of passed a certain threshold and it fixed them. But if they would be able to use the information after the winter, this is not from Sweden, it would be possible to identify a longer schema and optimize the budget and do all 3 of them. Because if you look on segment 1, it has the worst trend over this period of time. So the degeneration is at the highest of segment 1. And this ties us into the last point, which is the structural bearing capacity. And this looks like a lot of gibberish. I think it's a lot of data and a lot of data points, hard to explain within 3 minutes. But on the left side, we have a model fit, and on the right side, we have the absolute values, where we're plotting our estimation of the bearing capacity and the actual bearing capacity using a falling weight deflectometer. And we look on trends and historical data. And if we refine it to go a little bit more to where we have lots of trends, and then the data becomes a little bit more narrow, but then you're starting to see quite clear patterns that you can identify sections in red that does need structural maintenance, most likely. Either you can do a inspection with a falling weight deflectometer, a real one, or you can just add another layer of asphalt, or I think Fredrik would probably have a better answer what to do if you don't do an in-depth analysis. But the same way, you can identify the places that doesn't need any inspection or extra care on the road. So this leaves a pretty small band of areas that you have to go and investigate if you want to set some thresholds. And this is kind of the way we want to approach things, that doing a screening, especially for more expensive investigations, can save a lot of money for road operators and owners. And I think that the takeaway is this box, and I already mentioned it, that if you try to fit a cylinder in a squared hole, it won't fit. So I think it's more important to get the expectations right, and look on the strength and the added value we can get from the new technology, high frequency measurements, because there are areas that wasn't possible to do before. For instance, the freeze-thaw cycle analysis, you cannot monitor the roads at that frequency with any reasonable budget. So looking at the strength, I think, is the key takeaway, and figuring out, I mean, how do you use a cylinder instead of a square cube, and also that we get the user perspective as well from the vehicles. So I think those were my 5 minutes of side projects we're doing. Any questions?
Thank you, Björn. Any questions for Björn? We have one question in the chat, but on the project. While Adela make herself ready for the next, maybe we can take that question from Fredrik Lekar.
Yeah, I was just wondering. I missed a few minutes of the presentation, so I don't know if I missed the information. Where do we stand on the project? Is it completed? Are we towards the end? What's the next step? What's to come?
Yeah, as I presented before, so we are right now somewhere in between phase 3 and phase 4. So there's an intensive work going on qualification of the supplier to the next phase, which is the next phase 4, and this will include the implementation at upscaling to use the services for the monitoring of road conditions on the entire Swedish road network. But there is still some work to do with the data quality, and of course with the activities internally in Trafikverket to how to implement this kind of information in the planning of maintenance, and what kind of knowledge we need to implement the full of the information in the daily works on road maintenance.
And the implementation phase will be done with all 3 suppliers, to understand.
There's a dialogue ongoing now. We can.
Okay.
This will be published very soon.
My question was: is there a competition to find the best solution of the 3, or is it something that could concern all 3?
I think, there's still a competition between all 3, and we have a clear picture about the future. I don't know, Fredrik, if you want to comment on that.
Can you hear me? It's
Yeah.
Yes, we can hear you.
It sounds strange on my side, but we are right now in the phase of negotiating how to go on with one or more of the 3 suppliers. So it's really too early to say something. Formally the phase 3, so the development phase of the project, ends I think in February or something like that. So after that we will disclose what's going to happen next 2 years.
Thank you.
Adela, go ahead.
Right. Thank you. I think you see my screen now, correct?
Yes. Yes.
Okay, perfect. So I wanted to give you another a look into another project we did also with the National Road Authority, but this time in the Netherlands. And this is the Road Monitor project that took place between 2022 and ended in September of this year. So we have some learnings from the project, and I think it's quite useful. There are quite some comparisons to draw between the 2. So that's what I would like to share in this round. This is the setup of the project. Road Monitor, this is the name of a national program in the Netherlands, and we provided them with a number of data analytics products around their 3 use cases. So number one, they were interested in asset management. So this is really very similar to what Trafikverket also did with these 3 suppliers in the realm of our project. And here in asset management, we provided the Dutch Ministry of Infrastructure and Waterways with surface events and roadworthiness. This is also what we provide to Trafikverket, as well as traffic signs. Then they were also interested in winter management. So there we provided them with slippery roads and micro weather, and the third dimension was road safety. So to give you more in-depth information in that, so asset management, what was interesting is on the one hand, we provided them with 2 data analytics products that Trafikverket is also used in this project with us, but the use cases are quite different. Not so much for surface events, that is detecting irregularities such as potholes, but very much for roadworthiness, because the climate conditions are very different in the Netherlands, and they're much less interested in seasonal changes in roughness and much more in monitoring long-term changes. And then traffic signs enabled them to build and update a digital twin of traffic signs. Then for winter management, this product that is called Microweather, basically it detects the air temperature and rain intensity and does that at a much more micro level than a static sensor, and this is especially interesting for the highway infrastructure. And also quite relevant also for highways are slippery road events, to basically just pinpoint winter management crews really there where an intervention is needed to de-ice the road. And then for road safety, which is quite far from the interests of Trafikverket in this project, the interest there was to understand what areas of the road network are most prone to accidents by looking at near misses, and doing that on the one hand at a point level, so what we call hotspots, or at a road segment level, what we call peak regions. So we provide them with contextual information about areas of the infrastructure that are dangerous, and also with real-time warnings, so they can have both more data for short-term interventions and more for long-term ones. And that was just to give you more context, but now really coming to the learnings part. We learned a few things in this 2.5 year project. First and foremost, how important it is to involve the road authorities at an operational level, really involve the users. So these are all the organizations that used our data, so not just the national ministry, but many of the provinces and some of the cities as well. So if we want the product to meet the needs on the field, we need to involve users. So we had a lot of direct users looking into the API data from this project. Second learning is, we are mostly a German-based team, and we are doing business very much internationally, and there are many cultural differences to overcome, not just from a country perspective, but also from a profession perspective. We, from the automotive world, trying to talk with road operators, And it was, yeah, a bit of a clash at the beginning between the German data scientists and engineers that are very precise and analytical, and the Dutch road operators that are quite blunt and very practical and down to earth. So in the end, with understanding and respect and humor, we built a common culture and appreciated our strengths and find our way to work together. But this just shows it's better to have longer projects than short ones, because there is such a learning curve that you need to have at the beginning. And then finally, a bit the same, like how do you fit a round peg in a square hole? For us, the learning was you need user stories. So we developed user stories that rallied everyone in the project around the same understanding for the problem statement, instead of just talking about how great our data is, but what's really the user story for the road operator and how can they use that data to make their job better. We also did a lot of co-creation, not just throwing the data over the fence to them and just letting them deal with it themselves. And we did that by a lot of structured regular feedback loops to improve then the data quality as well, and a lot of workshops and visits, inside visits as well, to build this cultural bridge and also align on expectations. And by the way, this was also a very innovative procurement process from the Dutch. So also there are a lot of similarities. Yeah, so those were a few learnings we got also from the Netherlands, and also there starts a new cycle of procurement for the new solution. So yeah, thank you for the attention.
Thank you, Adela. So exciting to hear. Time is moving fast. Please write any questions for Adela in the chat, and I hope she will answer them. And now, Jonathan, it's your turn. And I put out a warning. Maybe we will keep on for a few more minutes, but we want to listen to Jonathan as well.
Yeah, for sure. I just thought I'd put a picture of my new car up as a starting post. But I actually just wanted to start by reminding everyone, although, as Thomas said, that Universes has been working with a smartphone, actually the heritage of the company really comes from the autonomous vehicle. We've worked for 7 years now developing perception systems for some production vehicles that are now out on the road. So computer vision components that are tasked with processing images from cameras on board, helping these cars to understand the world around them, the rich data that exists around them, as part of delivering an ADAS and autonomous vehicle capability. And it's actually that work that made us realize initially how difficult the road management task actually is, and made us really think that the rich data that these vehicles are harvesting could be useful in future for the road management applications. And that's why we built 3D.ai, which is the system that's been tested and being used in this project to date. I think the observation, I think we've talked about this before, and Adela and Björn have highlighted this, is that the automotive industry is on its own path, is on its own trajectory, and trying to get that automotive industry to truly understand the problem space of the road management industry is a cultural challenge. It's a technical challenge, and there's many issues to address, and that's why we started using the smartphone to start developing the system, as it were, all with a view to at some point in the future replacing it with the autonomous and ADAS enabled vehicle, all with a view to improving safety, reducing carbon emissions, and increasing productivity in the road management space, of course. And I think what we've really learned a lot, both through this project and other engagements, of course, is that actually the value add is a little bit in the way you collect the data. I mean, of course, it's more efficient to use vehicles that are out there, but it's what you do with the data once you've got it. That's where the big gains are to be had. And you can see our dashboard there. It's actually using image recognition to identify the different segments the images into different potholes and cracks and different surface damages, and then estimate. You can see the polygons on the right that show you the surface condition. And I think it's just helpful to say that in other, not necessarily here with TrafficVerkit, but in other territories, and the currency gives it away, just actually why this makes such a big difference. And if you think about a portion of road in the UK where we've been doing some work, it's over £100,000 for that portion of road to carry out work on the road to extend the life of it based on traditional methods of inspection and surface inlay and this kind of thing. If you actually adopt more advanced asset management techniques where you're actually truly understanding and modeling how this surface is eroding and intervening at the right time, perhaps with some surface dressing, you can reduce that cost. But actually it's when you combine 3D AI as all this high frequency data that we talk about, that really allows you to then say, here in this example in the UK, we can cut the cost by a factor of 4 and by the same road extension of its life. And that's really where you see the driver for this change. When we've talked before about why people should do something different, why they shouldn't do what they did yesterday, they should actually change. It's when you can highlight these kinds of numbers to say, if you do it differently, it is a step change in how you can operate, is a step change in cost reduction, in time reduction. And this is what we're able to show thanks to a lot of the technology that we developed partly in this project, but we're certainly able to deploy and test in this project, but then use elsewhere in the market as we go forward. I think just another interesting observation about this project and how we've had to adapt a little bit. Of course, we're not yet working with production vehicles. We're using retrofit, these smartphone devices. What we've had to do is adapt a little bit to be able to scale up the data collection. TrafficVerkit, when they think about road quality assessment, they think about it more or less in two strains, either the long-term investment or the sort of everyday maintenance. And we're able now, through the work under this project, to gather data and add value in that long-term planning effect. But in order to scale up the data collection, we've actually engaged with a whole nother part of TrafficVerkit, who actually are responsible for what they call BAS contracts. So this is where the Sweden is divided into 108 different sections, and responsibility for the everyday maintenance of those different sections is devolved to someone, some sort of contractor, and we can work with those contractors to collect data. That data that we collect is then reusable. So we're actually killing two birds with one stone in that sense. So we are collecting data that has been refined and shaped both through work in this project, but now adding value in different contexts, still surface condition assessment, but a different context for TrafficVerkit. So just to give you a flavor of how we can take what we've learned in the project and then expand into different places. And then of course, because it's we use images, we use cameras, there's actually lots of different things you can see in the image. So here's an example of actually detecting traffic signs. And once we've detected those traffic signs, we can compare the sign detection, for example, with the speed limits. And here is again a situation in the UK where we've highlighted the speed limit signs don't match the database. It's actually a roadwork here, and that's why. So there's good reasons. We can also highlight where there's work that needs to be done. And so now we help our clients around Europe to identify where traffic signs have faded and need replacing, or perhaps where they've been occluded and cause unsafe situations. And I think just it's been quite rapid and whistle stop, but I wanted to just dwell on this last slide to then say, actually, when you start to really think about the possibilities, that what work we've carried out in this project is really just the tip of the iceberg. Here we're very much focused under this project on the surface condition of the road, which is a critically important part, and that's what we're doing, and now expanding that further afield. I've talked already about the traffic signs, but there are many other asset classes that you can start to think about. Central lane reservation barriers, road markings. I think as Björn mentioned, that these are very much a place where a camera can pick these up, can look at them and say, are they fit for purpose? Roadworks, of course, and streetlights. I think this is a really interesting example of an asset that typically one might not think so much about. But actually, this is a huge consumer of electricity. It's a huge generator of carbon emissions. And if we can have an accurate assessment, not only of an inventory of how many streetlights we have, then we can have a much better idea of our energy consumption and perhaps even in some cases reduce our electricity bill and also understand which streetlights need to be improved to be more energy efficient in terms of LEDs. So I think, yeah, just to finish, I think there is, I think what we showed in this project is the potential for this kind of data, but it's really just the beginning. I think what we're seeing now is that the road management industry is beginning to understand, thanks to groundbreaking projects like this, what is actually possible with this kind of data. And despite there being some hurdles and issues to address with change, the direction of travel, I think, is very positive and exciting.
Thank you, Jonathan, and thank you, Adela and Björn also. Clearly, there are many interesting things happening within this field and nearby fields. Time is running up, and I will leave the last words to you, Fredrik.
Yes, interesting webinar, but we are at the end of the session, so I'd like to thank everybody for participating, and particularly the speakers, and also you, Bodil, for moderating the session. Just want to let everyone know that we make the presentation, the material available to all registered users. So if you have used the link but not registered, just send us your email so we can be in touch with you afterwards. All right. Thank you very much.
Thank you all. Take care.
Thank you.
Thank you.
Right.